Why was reinforcement learning crucial for AlphaGo's success? Imagine a computer learning to play a game so complex that even humans find it difficult to master. That's exactly what happened with AlphaGo. It was not just about coding rules. It was about teaching a machine to learn from its own experience. Reinforcement learning played a big part in this. It allowed AlphaGo to improve by playing millions of games against itself, learning from each move. Instead of following fixed instructions, it learned which moves led to winning and which didn't. This approach is similar to how humans learn, from trial and error. Reinforcement learning involves an agent, which is the program, interacting with an environment, which in this case is the Go board. The agent makes a move, then gets feedback based on whether it wins or loses. This feedback is called a reward or penalty. Over time, the program gets better at choosing moves that increase its chances of winning. AlphaGo used two neural networks trained with reinforcement learning. One network suggested promising moves, called the policy network. The other predicted the chances of winning from any position, called the value network. Together, they helped AlphaGo evaluate complex board states and pick the best move. What made AlphaGo's reinforcement learning special was how it combined deep neural networks with self-play. It first learned from human expert games to get a basic understanding. Then, it played countless games against itself without human help. This self-play allowed it to discover new strategies that humans hadn't thought of. It kept improving by learning from each game, which is why it could beat top human players. The game of Go has more possible positions than atoms in the universe, so traditional programming couldn't handle it. Reinforcement learning made it possible for AlphaGo to handle this complexity. In robotics and artificial intelligence, reinforcement learning shows how machines can learn to make decisions in complicated situations. Robots can use similar methods to learn how to navigate, manipulate objects, or adapt to changing environments. Reinforcement learning helps autonomous systems improve through experience, without needing explicit instructions for every task. So, the reason reinforcement learning was essential for AlphaGo's success is that it gave the system the ability to learn and improve on its own. It turned a program that followed rules into an intelligent agent that could develop new strategies. This approach allowed AlphaGo to perform at a level beyond human champions, solving a problem that was once thought impossible for machines. Its success highlights how reinforcement learning can push the boundaries of what artificial intelligence and robotics can achieve.